There are no sales of any kind associated with this video or channel. I do not sell firearms, firearm components, or offer any services. I'm not encouraging or advising anyone to build or modify firearms. This is for entertainment and educational purposes only. Hey, what's up everyone? This video will be about my own barrel porting design that I call the Trident port. I'm not very creative with names, so thanks to the two viewers who recommended that in the comment section of a previous post. Also, shout out to my boy Poseidon, aka Neptune. I ran into him once, the Old Town Square in Bologna, Italy. Look at this shit. He's got his Trident, dick out, got mad bitches, shooting what I can only assume is seawater out of their titties. What a pimp. Anyways, I employed this porting design in this recent 4.15 build, and I have done some testing with it. In this video, I will cover the design details, machining process, testing and analysis. Let's get into it. The idea with this design is that I wanted something unique to a Tri-Top 1911 slide, a design that has ports on all three faces. I decided to use slots because I thought those would look cool. I also drew some inspiration from the Atlas EOS. I've found that I like to keep my slots small in diameter and not very long, and always longitudinal to the bore axis, not transverse. This minimizes jacket separation, spalling, and accuracy loss. Originally, I was going to put them in a line across the top of the barrel like this, but that didn't leave enough material between the slots and the bore. Through my testing, I've observed that ports that are too close together are more likely to disrupt the bullet as it passes. I believe this is because the small amount of area between the ports causes a pressure point on the circumference of the bullet, and it makes it more likely to come apart. So I offset the top port, the one that will be contributing the most to muzzle flip reduction because it's pointing straight up, rearward towards the chamber. That means it will see the highest pressure and longest dwell time. I spaced it back far enough to give me the space between the ports that I want inside the bore. I wanted to have extra slot length in front of the ports to minimize how much gases and particulate get blown around between the slide and the barrel. A ported barrel generally fouls up a pistol much quicker. This would allow more time for gas to vent out of the barrel before the ports are obscured by the slide. I have ported a bushing barrel 1911, and I wouldn't recommend it. Since the barrel is a smaller diameter, there's a big gap between the top of the barrel and the ID of the slide. A lot of gas gets in there and fouls it up. Bull barrels are a better candidate for this because a larger diameter is much closer to the slide ID. Now, a question I got is, would this extra clearance in front of the ports also possibly increase performance? The idea is that the gas has more time to escape the ports, pushing the muzzle down before the slide travels rearward far enough to cut off the gas flow. I don't think so. The bullet leaves the barrel and dumps the rest of the contained gas pressure in the bore behind it before the action unlocks and the slide starts traveling rearward by itself. Gas, may still be exiting the ports, but it's residual and at low pressure. So I doubt it would still be contributing to muzzle flip reduction. Having this top inline port further back also minimizes how smoked the front sight gets. This may be important for fiber optic or night sights. Not important to me as I just run, blacked out backup irons with a red dot. Anyways, I constrained the top slot between these two serrations, and I projected some geometry and put the rear of the slots on the 45-degree faces tangent with an imaginary line connecting the side and top serrations. Then I placed all of this in relation to the front sight dovetail and adjusted the slot length in the slides and the barrel port length. The center length of the ports was adjusted due to space constraints and also not to go above what I have experimentally found to be excessive length that results in accuracy loss, but also to hit a certain overall port cross-sectional area. In this case, it was quite a bit more port area than the minimum I generally target because I wanted to really drive the muzzle down. So those were some of the things I was considering with this port design. I have ported a lot of pistols, done a lot of testing, and I've developed my own set of parameters that I like to adhere to in order to make my ports perform like I want, and not just from a muzzle flip reduction standpoint. All right, onto the machining. I always make a detailed 3D model, then I can derive an associative drawing and add dimensions to that in a way that will reflect how I will be machining them on a manual 3-axis mill. I put the slide in the mill and machined the top slot at the same time I did the top serrations. Then I removed the slide from the vise, installed the barrel with my barrel holder, put it back in the vise, and machined the top barrel port. I have designed and 3D printed slide holding fixtures for Atlas slides. I use these for slide and barrel machining and also machining the profile of the compensator blanks to match the profile of the Atlas slides. It's much quicker and easier than setting up a tilting vise. With the slide at 45 degrees, I can't zero my y-axis by touching off on the sides of the slide, so I use a gauge pin in the slide barrel passage to locate my slide slot over the center of the bore axis and machine the slide slot. After I did that, I removed it, installed the barrel and barrel holder again, and used a bore gauge pin to zero my y-axis. These fixtures also have clearance for the barrel holder. And then I machine my barrel port. I have another 45-degree fixture, tilting it the other way, and put it in that and repeat the process for the other side. I deburred the barrel ports in the bore with a piece of 600 grit sandpaper wrapped around a brass rod. I did some hand cleanup and broke the edges of the ports in the barrel and slots in the slide with a fine needle file. I test fired this pistol before the barrel was ported so I could collect this data to determine the muzzle flip reduction of my port design. I have shown this testing in multiple videos of mine, but I'll quickly run through the process and how I collect and analyze the data. Keep in mind I don't have a ransom rest. I'm the one doing the shooting, and that's likely where the largest source of uncertainty comes from. I use a 240 frames per second setting on my phone camera to capture a string of shots with the barrel in the unported and ported conditions. I use the same ammo and recoil spring for each test. I fire a string of 7 shots, but don't collect data from the first shot because that one allows me to settle into my grip, or the last shot because the slide locks to the rear and changes the recoil impulse slightly. I take 2 still captures from each shot, one right before the shot is fired and one at max muzzle flip. I overlay the 2 images and put them into image analyzing software and measure the angle between the 2. There's some uncertainty associated with this method. I believe it's about plus or minus 1/4 of a degree. I take the average of the muzzle flip angle readings and also calculate the standard deviation for each data set. I graph the average values and add error bars that are equal to 1 standard deviation above and below the mean value. Since I am comparing 2 different states, ported and unported, of one entity, the barrel, I use a percentage reduction formula to quantify the performance of the porting job. Here's the formula for that. My data indicates the porting produced a muzzle flip reduction of somewhere between 33 and 41% with a mean value of 37%. Now that's a pretty big range, but I feel it's a fair way to report this data due to the uncertainty associated with my tests and data collection methods. There's some other, uncertainty we can consider. Between the 2 tests, the slide and barrel mass were different, right? There's a bit of material removed for the serrations and the ports and the slide and the barrel. The slide and the frame were raw 4140 beforehand. Now they're nitride treated, so there's a different coefficient of friction associated with the slide and the frame sliding past each other. I didn't do the testing on the same day, so the weather and environmental conditions weren't the same. There's inconsistency in ammo. I still think the largest factor is probably that a human was doing the shooting. 5 data points for each test and a pretty small standard deviation do make me feel a bit better about reporting that mean value, though, and feeling confident that it is somewhat representative of reality. I'm going to throw some bonus data and analysis at you guys. It was easy to collect while I was at the range, and I was curious about it. I wondered how much benefit there was to running a weapon light on the muzzle of this pistol. So I tested with the ported barrel, same ammo, same recoil spring, but with and without the light. And the light provided a 21 to 31% reduction in muzzle flip with a mean muzzle flip reduction of about 26%. So do with that information what you will. I just thought it was kind of interesting. I tested accuracy before and after porting. These holes in the barrel disrupt the bullet as it passes. In the worst case, the ports can shave off parts of the jacket or allow pieces of lead to separate from the bullet, destabilizing it after it leaves the muzzle. I size my ports and arrange them to minimize the negative effects on accuracy. Before porting, this was my best group. 1.25 inches with 115 grain full metal jacket PMC bronze ammo at 25 yards from bag support. After porting with the same ammo, same distance, bag support, this was my best group, 2.6 inches. So it opened up. The group size about doubled. It is a sub 3-inch group with FMJ ammo from 25 yards out of a 4.15 inch barrel still acceptable. It sure is to me. This isn't a bullseye pistol. I did shoot some groups with Spear Gold Dot 124 grain jacketed hollow points, and my best group with the ported barrel was 2 inches. The unported barrel was raw stainless. After it was ported, it was also DLC coated. Could this affect the accuracy? Yes. By how much? I don't know. Anyways, this porting job maintains an acceptable level of accuracy in my opinion, and certainly for my purposes with this firearm. I am quite concerned with what comes out of these ports other than hot gases and some powder residue. Shooting a ported pistol from retention put me in the hospital. I wanted to see what was coming out of the ports with this design. However, I did the testing with cardboard this time instead of my face. I shot ammo with different bullet types while holding a piece of cardboard over the ports. Bullet construction affects how likely they are to come apart when they pass the ports. So let's look at the results. This is a Blazer brass bullet. It is not jacketed, it is just copper plated. These like to come apart. Here's what the cardboard looks like. You can see some holes in it. Quite a few holes. Some of them are decent sized. Next up is the PMC bronze. This bullet is jacketed, but you can see that the back of the jacket is open, exposing the lead core. Here's what that cardboard looks like. There are much less holes. There's still a few, some here, but they're quite a bit smaller. There's a little burn mark there. What I'm seeing here is not really concerning to me. This is a Hornady Critical Defense 135 grain plus P fully jacketed hollow point. The jacket completely encompasses the lead core. Let's look at that piece of cardboard. Really pretty similar to the PMC. There's a couple little holes here and there. Some little scuff marks and burn marks, but again, this doesn't concern me too much. So minimal spalling with the two jacketed bullets, in my opinion. More chunks coming out than I would like to see from the plated bullet, but hey, I guess that's why they say on the box not to shoot it through a ported barrel. However, the chunks that came out and went into the cardboard appear to be quite a bit smaller than what I had to have surgically removed from my skull. This port design is quite a bit less noisy and concussive than some of the other ones I have shot. It's not nearly as obnoxious or teeth rattling when shooting under a cover or next to a wall. I'm pretty pleased with this, especially after feeling how it tames muzzle flip so well. Now, I don't really consider noise when designing ports. I just accept that it will probably be obnoxious, but I was pleasantly surprised with this one. I don't have a definitive answer as to why, but throughout my testing, I've observed that holding all other factors constant like overall port cross-sectional area, port shape, and spacing. Smaller ports tend to be a little bit less obnoxious. I generally keep my ports on the small side for reasons that I've already discussed, but it may also be of benefit here. I elongated the slots in the slide in front of the ports in an attempt to minimize fouling inside the slide. The tight fit of the bull barrel to the slide barrel passage undoubtedly helps with this. Can I quantify the amount of fouling or rate at which it accumulated and compare it to other ported pistols or an unported pistol? No. But qualitatively, I feel like this didn't get that much dirtier than an unported pistol. The first time I took this out, I shot roughly 400 rounds through it. And this thing was not dirty like I would expect a ported pistol to be. I was really surprised. I didn't test for velocity loss. Sorry, I know some of you probably really want to see that, and you were going to ask in the comments anyways, so I'll go ahead and address it. I'm not that concerned with velocity loss based on the testing that I have seen others do, nor am I concerned with it based on the application of the pistols I port. I'll drop a link in the description to a Sage Dynamics video about ported barrels that I really like. What I have seen is that the velocity loss due to porting is generally tens of feet per second, not hundreds. Sometimes it's even within the standard deviation of the bullet velocities coming out of an unported barrel. My understanding is that the bullet picks up most of its velocity in the first couple inches of the barrel. If that's correct, it would make sense to me that the ports at the end wouldn't affect velocity that much. Acceleration is tapered off and the bullet passes the ports and then quickly exits the muzzle. If you ported a really short barrel, or the port design had multiple large ports close to the chamber, maybe it would result in significant muzzle velocity loss on the order of hundreds of feet per second that could indeed affect the performance of different types of ammunition. Could you, in theory, use the velocity loss to calculate or estimate how much work the ports are doing, how much energy is being redirected, and even correlate that to muzzle flip reduction? Yeah, maybe. But if the velocity difference gets lost in the noise of the inherent inconsistency of some ammo, then good luck. Now, if someone wants to buy me a nice chronograph, then I'll do the testing. And, while you're at it, throw in a ransom rest as well. So, I am really pleased with this port design. I feel comfortable carrying it forward to other builds now that it has passed my requisite testing and evaluation. It performs well in all the areas that matter to me. I hope this was interesting, informative, or entertaining to you in some way. Let me know what you think of this design, the performance, the testing. And I have an important question for you. Do you think this design is better than the PP port? Thanks so much for watching. I'll catch you next time.